All right, so this is the study guide for the Algebra 2 Trig fall final. So we're going to go ahead and just go through each one of the problems here. So we're going to start with, how would you translate a graph of y equals negative x squared to produce the graph of y equals negative x squared plus 3? So the only thing is we are doing is adding that 3 to the end. And this is a y movement, which means we have to either go up or down, and we don't change the sign because I'm not going in or out of parentheses. So this would be, since it's positive, it would shift up 3 units. So shifting up 3 units would be C, or translating is a fancy word for shifting. Which transformation from the graph of the function f describes the graph of 10f of x? So when we have a number in front, we're either talking about a vertical stretch or a vertical compression. And you don't need to worry about horizontal for the final. A vertical stretch is a number that is greater than 1, and a vertical compression is a number that is between 0 and 1. Because we're talking absolute value because a negative does a reflection. So either one of those numbers, this number is bigger than 1, so it's got to be a vertical stretch, and it would be a vertical stretch by the factor of 10. All right, we got to talk about the domain and the range. So the domain is the x values. So my smallest x value here is a 1. You'll notice they have that on 2 different things. And it's a less than or equal to, because there's closed, x, less than or equal to, and my biggest domain value is 6. Now, we could get that totally. We don't even need to look at the range because it's got to be answer B, but we're going to look at the range because it might not be quite that easy on the final, or I might only have you find one or the other. So the range, remember, is your smallest y value. The smallest y value on this graph looks like it's 1, and it's a y less than or equal to, and it looks like the highest y value on the graph is 7. So I do agree with their answer there. We're going to solve to find the inverse. So remember, the big thing on finding inverses is that we switch x and y. So we're going to pretend like that f of x is a y. So I'm going to take those and I'm going to switch the x and the y value. I'm sorry, I do not know what happened there. My screen blanked out. See if I'm still recording here. Yes, I am. All right, I apologize for that. Something happened with my screen. Sometimes the surface is not always reliable. So we're going to switch x and y. So I'm going to start by switching the x to the front and 3y minus 8. And then I'm going to go ahead and I'm going to add the 8 to the other side. So I get x plus 8 equals 3y. And then I'm going to divide by 3. And remember, you have to divide everything by 3. So you've got x over 3 plus 8 over 3 equals y. And the y could be either way. We typically want to change it back to function notation. So they're using g to denote their inverse. So I'm going to go ahead and put the g in the front. So g of x equals x over 3 plus 8 over 3. So they're writing it as 1/3 x plus 8 over 3. So it would be this one here. All right, we need to solve. So remember, we have, when it's like this, it's a less than, which means and. And when it's like this, it's a great, or, which means or. So in this case, we have a less than, we're looking for an and. So the 2 answers that are ands are A and D, so C and B are actually out as choices. So remember, this is where we split it into a positive expression and a negative expression. We're going to go ahead and add or subtract the 1 from both sides. So you get 2x less than or equal to 6. Then we're going to divide by 2, so x is less than or equal to 3. I'm going to distribute the 1 in, so negative 2x minus 1 is less than or equal to 7. I am going to add 1 to both sides, so negative 2x less than or equal to 8. And then I'm going to divide by a negative 2. When you divide an inequality by a negative, you have to flip the sign. So 8 divided by negative 2 is negative 4. And remember, we need to write the word and in between, but they wrote it the fancy way, so I have to do that too. So we've got to go the smaller number first, less than or equal to x, less than or equal to 3. So it's got to be D. We need to find the vertex and decide if it's a max or a min. We definitely know this is a minimum because it's down low, so this one that says maximum is out. And then I need to read that point off the graph. It looks like we're going out 1, 2, 3 on the x. And we're going down 1, 2, 3, 4, 5 on the y. So 3, negative 5, and it's a minimum. All right, here we're comparing the graphs. And remember, when we go into or out of parentheses or absolute values, we have to change the sign right there. So I'm really talking about negative 6. And remember, when it's inside, you either do a right or a left shift. And if I'm going negative, I have to be left. So this would be a graph that shifts left 6. So the dashed line is the absolute value of x graph. So we need to look at this solid line. So it looks like the solid line that's going, this one is definitely going down. That one's definitely going up. So those two graphs are out. It looks like this one is going to the right, whereas this one's going to the left. So it's got to be graph D. All right, we need to solve. It's a quadratic. And if I look at all of my answer choices, there's nothing that looks like it factored. So some of them even have i's and they've all got radicals. So I'd probably immediately go to the quadratic formula. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative the b value. Remember, it's a, b, c. It has to be in order from the squared, though. So the b value is 5 plus or minus the square root of 5 squared is 25 minus 4 times my a, which is 4, times my c, which is 2, all over 2 times my a, which is 4. So negative 5 plus or minus square root of 25. We've got 16 times 2 is 32, so negative 32 over 8. So negative 5 plus or minus square root of negative 7 over 8. Remember, when we see a negative under a radical sign, we have to pluck our i's out. Over 8. And then the difference in our answer and their answers is they split it up into two fractions. So they said negative 5 over 8 with the common denominator. And the square root is 7 over 8. And they happen to stick their I in the back. So it looks like it's got to be answer choice B. Which of the following is equivalent to the square root of negative 121? So we're going to go ahead and pluck an I out. And the square root of 121 is 11. Easy, easy peasy. Don't get that one wrong. All right, we need to simplify, which means we need to FOIL. Okay. So 3 times 2 is 6. And then you've got 3 times negative 3i is 9i. 2i times 2 is positive 4i. And then 2i times negative 3 is negative 6i squared. Remember, I squared is equal to negative 1, so that means this is better known as positive 6. So now we're combining like terms. 6 plus 6 is 12. And then negative 9i and positive 4i is negative 5i. we need to write the standard form of a circle with this center and the radius of 3. So remember, your skeleton for that is x something squared plus y something squared equals, and this has to be the radius squared. So to go in or out of parentheses, we swap our signs. So we would have to say +4 and +1. And then we have to take this radius number and square it, which would mean 9. So it is looking like the first answer choice, actually. Here we have to decide what goes in the blanks to complete the square. So remember, to complete the square, we take this and we divide it by 2, which would give me 8. I'm going to take the 8 and I'm going to square it, and that will give me 64 to both sides. So what will go in the blanks is 64. I need to solve the system, and it's a quadratic system. We're going to take this, and they're already both solved for y, so I'm going to substitute it in. So we get 5x plus 9 equals x squared plus 6x plus 3. I need to move both the 5 and the 9 to the other side because I have to get it equal to 0 because it is a quadratic. Sorry. So we get 0 equals x squared. I'm subtracting the 5x, so I get positive x. 6x minus 5x is x. I'm going to subtract the 9, so 3 minus 9 is -6. It's a quadratic, so what we're going to do with the quadratic is we're going to do a magic x. So I need two numbers that multiply to -6 and add to 1. So I'm thinking 3 and -2. I don't have a leading coefficient, so I don't need to do a box. So I'm going to just do x plus 3 times x minus 2. I'm going to use zero product property to set each one of them equal to 0. I'm going to solve for x. So I'm going to subtract the 3. I'm going to add the 2. But you notice that those are not my answer choices. I have to actually plug them back in to solve. It doesn't matter which one I go into. I'm going to go into this second one here. So I have that y equals 5 times -3 plus 9. Well, 5 times -3 is -15. Plus 9 is -6. So one of my points is -3, -6. So it looks like it could be, it could be either A right now or B. Looks like these two are out. Then I got to plug in a 2. So again, I'm going into the 5x plus 9. So y equals 5 times 2 plus 9. 5 times 2 is 10, plus 9 is 19. So it looks like my other point is 219. So it's definitely looking like answer choice B. But it's not letting me go to the next one. Oops, sorry. All right. What's the y value when you solve the system? The nice thing about this system, it's nice and it's not nice. You can choose to do it either way, whether you want to do substitution or elimination. It's set up for elimination, but it doesn't tell you one way or the other how you have to do it. The hard part is it wants us to solve for y, but we end up eliminating the y, which means you have to go all the way to solve the system on this one. So -3x plus 6x is 3x. The y's go away because they equal 0. And then -22 and positive 34 is 12. And then I'm going to divide by 3. So x equals 4. And then it doesn't matter where I substitute into. I'm going to choose to go into the first one, because that's just the x value, and I have to find the y value. So, sorry. We've got -3 times 4 for the x, plus 2y equals -22. -3 times 4 is -12. And then I'm going to add the 12 to the other side. When I add the 12 to the other side, I get 10. -10, sorry. And then I'm going to divide by 2, and I get -5. So my y value is -5. On this one, which is a graph of an even function with a positive leading coefficient. Now think about this. We could really easily change this for a test to an odd function with a positive, an odd function with a negative, an even function with a negative. So all of those things are here and they could easily be changed. So even functions are functions where the graph points the same direction. So this one is even and this one is even. Odd functions are where they're opposite. So this one is odd and this one is odd. When even functions point up, they are positive. And when they point down, they are negative. And then, so this has to be the answer here. But let's talk about the odd function just in case it's odd on the final. Remember, if we connect our endpoints and we have a positive slope, then that's a positive even function. And if we connect our endpoints and we have a negative slope, then it is a negative even function. Or sorry, a negative odd function. All right, we've got to find the graph of the polynomial. So the best thing I can do is start by looking at the zeros. So remember to calculate your zeros. You're going to set each one of these equal to 0, each one of the factors equal to 0, and solve for them. So I've got x equals 1, x equals -1, and x equals 4. So I'm going to look for those things on the graph. So I'm looking for 1, -1, and 4. Definitely not graph A. 1, -1, and 4. Graph C is a possibility. 1, -1, 4. Graph B is a possibility. 1, -1, and 4. Graph D is out. So now I need to decide which between C and B, and notice one is a negative direction and one is a positive direction. So one's a negative direction, one's a positive direction. I've got a positive out front, so it's got to be graph B. Okay, we need to multiply. So we're going to, I would probably get out the box. So that keeps my work nice and organized. So I've got B plus 3 and B squared plus 2B plus 1. So B times B squared is B cubed. B times 2B is 2B squared. And B times 1 is B. 3 times B squared is 3B squared. 3 times 2B is 6B. And 3 times 1 is 3. And most likely across our diagonals are like terms to combine. So I get B cubed. 3b squared plus 2b squared is 5b squared. 6b plus b is 7b, and then this plus 3. It looks like answer choice B. We need to subtract, so I'm going to go ahead and start by distributing that negative in. So we've got, I'm going to just copy this first one down, x cubed minus 2x plus 3. And then we've got minus 3x squared minus 4x minus 3. I'm going to combine my like terms together. So I'm putting together, x cubed doesn't have a like term, does it? So it's just x cubed. My x squared also doesn't have any friends, so I'm just going to write x squared down. Then it looks like I've got negative 2x and negative 4x, which would be negative 6x. And then positive 3 and negative 3 actually end up canceling because they're opposites, so they would become 0. So it looks like, I don't like any of the answer choices. What did I do wrong? Negative 6. Interesting. X cubed minus 3x squared minus 6x. Oh, I have a typo, don't I? Look at that. I messed up my 3's. So let's try that again. I didn't distribute. So what I just missed here was negative times a negative should have been positive. So 3 plus 3, or 3 times 3 plus 3 is 6. So it should have been answer choice D. All right, we need to expand the product, which means we need to get to, I'm going to start with writing out my fourth row of Pascal's triangle. So you'll need to know your Pascal's triangle for the test. So you've got 1, 4, 6, 4, 1. And then I'm going to put an X and a 2. And the first exponent I put on my X is whatever that highest exponent is there. So 4, 3, 2, 1, 0. And we're going to do the same thing from the 2 and count the other direction. So 4, 3, 2, 1, 0. We know that anything to the 0 power goes to 1. So this first term, we've got x to the 4th. And then we've got 4 times 2, which is 8x cubed. 2 squared is 4. So 6 times 4 would be 24x squared. 2 cubed is 8. 8 times 4 is 32x. And then 2 to the 4th is 16. So let's see. I'm seeing... Uh-oh, what happened? Oh, I missed the negative. We've got a negative, a negative, a negative, a negative, and a negative. So let's see how that fixes it. That changes it. So this one would have been because it's an odd exponent, it would have stayed negative. An even exponent would have made it still positive 4. An odd exponent would have made this a negative 8, which makes this a negative 32, and then 2 to the 4th would still be positive 16. So that then makes it answer choice D. I need to find the remainder when we're divided by x plus 3. I would probably use synthetic division for this since I only need to find the remainder. So I'm going to remember we switch our sign here. So it's got to be negative 3. And then my coefficients are 2, 3, negative 1, and 1. I start by dropping my 2. Negative 3 times 2 is negative 6. 3 and negative, adding it up, 3 plus negative 6 is negative 3. Then I multiply again. Negative 3 times negative 3 is 9. Negative 1 and 9 is 8. And negative 3 times 8 is negative 24. And 1 and negative 24 would be negative 23. We need to figure out which of the following is a factor, so they don't give us both. I've got 4 terms, which means that I'm grouping this. So out of the first group, I'm going to take out an x squared, and I'm left with x minus 3. Out of the second group, remember I'm leading with a negative, so I'm going to take out a negative 4, and I'm left with x plus, x minus 3. My ugly greatest common factor is x minus 3, so I'm going to take it out. And then I'm left with x squared minus 4. Now, unfortunately, I'm not done factoring. I can still factor that more because it's 2 terms and they're both squares, so I have a difference of squares. So difference of squares goes into a binomial times a binomial. The square root of x squared is x. The square root of 4 is 2. We make 1 a plus and 1 a minus. So it looks like this is the factor that they have represented there. We've got to use Pascal's triangle again to expand. So I don't have my calculator on me, so we're going to have to kind of guess here just a little bit. Let's see, I probably have my calculator. Oh, I found it. Grab my phone. Okay, ready to go. So we have to go to the 4th row of Pascal's triangle, which is 1, 4, 6, 4, 1. And then I'm going to put a 3x and an 8 after each one of these. Okay, and then I'm going to count down 4, 3, 2, 1, 0. And I'm going to count down from the 8 on this end. 4, 3, 2, 1, 0. Anything to the 0 power we know is 1, so those ones go away. Okay, 3 to the 4th is 81, x to the 4th. So I'd immediately get rid of a. Then we've got 3 cubed is 27. So I've got 4 times 27 times 8 is 864. And, let's see, we got a negative in front of the 8 that I missed. So it's that is negative 864 x cubed. Notice I'm done right there if I wanted to be. I'm going to double check the answers on the rest of it just in case I can't eliminate it quite that quickly. 3 squared is 9, and negative 8 squared is 64. So we've got 6 times 9 times 64 is 3,456x squared. The 3 is just going to be a 3. Negative 8 cubed 8 is negative 504. And then 4, so 4 times 3 times 504 is, that's not what I got. What had happened? Let me try that again. 8 times 8 times 8. It's not 504, it's 512. All right, and then times 4 times 3 is negative 6,144x. And then negative 8 to the 4th, we know it's going to be positive. So is 4,096. All right, we're going to divide. And even though we didn't see one like this necessarily in what we were doing, to use our synthetic division, we really don't want a leading coefficient there. So the best way to do this one is by long division. And I thought this one was a little bit easier than the long division we were doing most of the time, so I went with this one. Interesting. 19x squared plus, I see what happened. Okay. Notice I did those out of order, so you need to put them in order when we put them in here. So we've got 6x cubed plus 19x squared plus 24x plus 19. Make sure they're written in order and make sure there's no gaps. So we're going to put a 3x plus 5 out front. Then you've got to ask yourself, how many times does 3x divide 6x cubed? And it goes in there 2x squared. Then I'm going to distribute this through. 2x squared times 3x is 6x cubed. 2x squared times 5x is 10x squared. Then we switch our signs because we're going to got to subtract. The 6x cubes cancel. 19x squared minus 10x squared is 9x squared, and we're going to drop down the 24x. What times 3x is 9x squared? We would get 3x. We're going to distribute. 3x times 3x is 9x squared. 3x times 5 is 15x. We're going to switch our signs because we need to subtract. 9x squared minus 9x squared is 0. 24x minus 15x is 9. So 9x, and we're going to drop down the 19. How many times does 3x divide 9x? And we would say that's 3 times. So 3 times 3x is 9x. 3 times 5 is 15, and we're going to switch our signs. And we know that 19 minus 15 is 4. So then remember, you take whatever you have for your remainder and you write it over whatever you divided by. So we've got an answer choice B. Which of the following is a factor? So we've got 3 terms, so we have to use a magic X. So 2 numbers, we multiply the first and the third together. So 2 numbers that multiply to negative 30 and add to negative 7. And that would be negative 10 and positive 3. Because I've got a leading coefficient, I also need a box. So the top left-hand corner of the box is 2x squared, and the bottom right's negative 15. And then you take the two numbers from the magic x and put them in the other two corners, followed by an x. Then you have to ask yourself what times what is 2. So that would be 2 and 1. My 2 is going to have to go on the left because it divides the 10x and does not divide the 3x. How many times does 2x divide negative 10x? It's negative 5. And how many times does 1x divide 3x? It's 3. And then you check it. 3 times negative 5 is negative 15. So we have x minus 5 times 2x plus 3. And it looks like the only one that is there is the 2x plus 3. I have to completely factor this. So first thing I'm going to do is look for a greatest common factor. It looks like my greatest common factor would be 5x. And I'm left behind with 2x squared minus 7x minus 4. And then I'm going to try a magic x on this back piece here to see if it works. So I need two numbers that multiply to negative 8 and add to negative 7. So I'm thinking negative 8 and 1. It's got a leading coefficient, so I do in fact need a box. So I've got to put the first term in the top left, which is 2x squared, and negative 4 in the bottom right. And the two numbers from the magic x followed by an x. Then I ask myself what times what is the 2x squared, and that would be 2 times 1. Again, my 2's got to go on the left. How many times does 2x divide negative 8x, and that would be negative 4? How many times does 1x divide 1x, and that would be 1, and then you check it. 1 times negative 4 is negative 4. So it's got to be 5x times 2x plus 1 times x minus 4. All right, we're going to factor. So it's two terms, and they're both cubes, so it's a sum of cubes. I'm going to start with my sign, so it's going to be a plus, and the other two have to be minus plus. And you'll notice that I could eliminate a and b just based on that. In fact, I don't need to do anything else. Look at my signs. This right here is wrong, so it has to be c, but I'm going to do that. I'm going to do the whole thing just in case. You have to take the cubed root of 8x cubed, which is 2x. Take the cubed root of 125, which is 5. And then we're going to square this term, which would be 4x squared. We're going to square the back, which is 25. And then we're going to multiply together for the middle, ignoring the sign, which would be 10x. All right, we need to subtract, so which means I need to get a common denominator, which means I'm going to do a magic x here to see if I have anything that's common. So I need two numbers that multiply to negative 6 and add to 5. So we've got, looks like 2, no, not 2 and 3. How about negative 1 and 6? So we've got x minus 1 times x plus 6. I'm going to circle what matches. So that gets written one time, and then I underline everything else, and that whatever I underline also gets written. This is where I multiply by what's missing. So we notice in this first one, the x plus 6 is missing, so I multiply by x plus 6. Distribute your 1, you get x plus 6. In this one here, there is nothing missing, so I don't need to multiply, but I do need to write down the minus 7. Then we're going to combine like terms. So we get x minus 1 over x minus 1 times x plus 6. This simplifies more because the x minus 1s can cancel. So we end up with a 1 in the numerator. So you get 1 over x plus 6. All right, so when we have division, we need to take this and we need to flip it and switch it to multiplication. So x squared plus 3x minus 10 over x squared minus 2x minus 15 times x squared plus 6x plus 9 over x squared plus x minus 6. Again, it's like a simplifying problem now. I could put parentheses around this all. It's giant magic. It's 4 magic x's that we've got to do. So I'm going to start with this one here. So two numbers that multiply to negative 10 and add to 3 would be 5 and negative 2. So x plus 5 times x minus 2. This one here, two numbers that multiply to 9 and add to 6 would be 3 and 3. So x plus 3 times x plus 3. This one here, two numbers that multiply to negative 15 and add to negative 2 would be negative 5 and 3. So x minus 5 times x plus 3. This one here, two numbers that multiply to negative 6 and add to 1 would be negative 2 and 3. So x minus 2 times x plus 3. The minus 2's cancel. The x plus 3's cancel. The other x plus 3's cancel. So I'm left with x plus 5 over x minus 5, which is A. All right, we've got to solve, so we want to multiply everything by the LCD. So I'm going to circle what matches, which is really only just the x. And then, so I'm circling the matches, which is the x. And then I'm going to underline everything else, and I also need everything else. So I've got 4 times x plus 30. So I'm going to multiply everything times that. I'm going to rewrite this first, though. 1 over 4x. And I'm going to have to pause because the baby is a-crying and needs his mama right now. So the last 6 problems will be in a different video. So we're going to have to multiply by 4x times x plus 30. 4x times x plus 30, and 4x times x plus 30. So over here, the x's cancel. I'm going to distribute this in because I know that negative 2 times 4 is negative 8. So I would get negative 8 minus 240. The 4x's would cancel. I distribute in the 1, so I get x plus 30. And then the x plus 30's cancel, and I multiply 7 times 4x, and I get 28x. I'm going to combine my like terms on this side, so I've got negative 8 and positive x is negative 7x. And then negative 240 plus 30 is negative 210 equals 28x. I'm going to add the 7 to the other side. Is 35x, and then I'm going to divide by 35, and when we divide by 35 we get negative 6 equals x. You want to check for extraneous, so make sure that the denominator does not equal 0, and it doesn't. So it looks like it's answer choice A. All right, I'm going to pause it there. You have to watch the next video to finish it up.